Hello, I want to talk a little bit about stylistic issues, and I prepared a little example here. So we just have our module header, and we have a single function, and let's just assume that implementing this product function has been the task that a student has been trying to solve here, right, or a developer. And this is the implementation of the product function. So the product function is supposed to take a list of integers, as shown here, and turn it into a single integer by computing the product of all the integers in that list. Okay? So how do we start looking at this? I mean, a good starting point is to first try to load this module and to try out the function. So let me try to do this. So we load the product.hs module into GHCi, and then I have the product function available, and I can just try to run this on a number of examples. So if I compute 3 times 4 times 5, I get 60. That sounds plausible. If I compute the product of the numbers up to 10, then that's already a little bit more difficult to judge, but this roughly sounds plausible as well. Perhaps let's do another one, like 5 times 5 is 25. Okay, well, so that seems fine. Or perhaps let's try a negative number just for checking whether something goes wrong there. That gives us minus 12. So, okay, so the correctness seems roughly all right. We haven't, of course, checked all possible cases here. Now, then let's look at the definition itself. So correctness is only one thing. A function should be clear and systematic and should follow common coding practices. And here there are a number of issues that immediately come to mind. And I think the first thing I typically look at are issues of spacing. So spacing is something which I think makes a program very much easier or harder to read. And it's not very difficult to be consistent about it, so let's try to always be it. So one of the ground rules in Haskell is that function application is denoted with a space, right? So this rule is not strict in the sense that Haskell is okay with interpreting something like we see here, product parenthesis open, array parenthesis close, as a function application, because the opening parentheses cannot be part of the product identifier. So Haskell will correctly end the product token here when parsing and start parsing something new, which then becomes the argument to the product function. But it is a good idea, and it is certainly idiomatic, to always put a space between a function and its argument. And the same applies to function applications on the left-hand side of a function definition. So even though it is okay to omit the space here in all these cases because there is a symbolic token following which cannot be part of the product identifier, it is still a good idea to always put the spaces there. Okay? And then we have another strange spacing situation here, where we have an operator where to the left of the star we have no space, and to the right of the star we have a space. And I prefer always putting a space on the left and the right, a single space on the left and the right. I guess it's okay to omit both spaces, but one should sort of go for a consistent version, right? Either no spaces on either side or a space on either side. And here we have another situation where there are 2 spaces to the left and 1 space to the right. I don't really like this either, so let's put a space here. And then we come to the less important one. So here we do have consistent spacing around this colon here, right? So that is fine, but I guess since we have been using spaces around operators and all the other places, I prefer slightly this one as well. And then with commas in list notation, that is a sort of a corner case, and I don't really have a strong preference. In fact, Haskell itself is rather clear that it does not put spaces after the commas, but sometimes people try to, because typographically that is often a little bit nicer. So this is something where I'm undecided. So let's leave it as it is for the time being. Okay. So I think that settles the spacing issues. By the way, it is common, or at least not uncommon, that people align equations in a function definitions along the equals symbol, and that is perfectly fine. That makes things a little bit easier to read. I think it's okay, it's a choice. You can do it, you can not do it, but if you do it, you should be consistent about it again. So you should not then have a single case which is not aligned, or you should not then have a case where you have something like this, right? So make a choice and then stick with it and be consistent about it. Okay, so that is all I currently have to say about the spacing issues here. And then another thing I'm always looking at are redundant parentheses. And sometimes parentheses are redundant in the strongest sense, but they help readability. For example, if there are multiple operators involved and one of the operators binds stronger than the other, you can still choose to surround the prioritized sub-expression with parentheses to emphasize that this one binds stronger. That is fine, I think. There are also cases, though, where they're really not necessary and they're just noise. And this is such a situation here. The parentheses around array, they're really not needed, right? Function application is denoted by space, and parentheses around an argument are only needed if the argument is sort of non-atomic and has to be grouped together so that it is clear that the function application really applies to the whole argument. But here the argument is just this identifier array, and that is fine. Right? Also note that I said already that function application binds stronger than any infix operator. So in this case, there's no need to put parentheses around product array. Right? This is really not necessary because this is just a function application, and therefore it binds more strongly than the multiplication operator. Okay. You could think that the parentheses here around fun::array are perhaps not needed, but that is wrong, right? Because then the same issue applies. Like, as far as Haskell is concerned, function application binds more strongly than any infix operator. Cons is an infix operator, so this would be parsed as the application of cons to a first argument, which is a call of product to fun, and a second argument, which is array. So now this would look to Haskell as if it is a definition of the cons operator, where the first argument has a shape that isn't even allowed as a pattern to occur on the left-hand side. That's why you get a parse error that says parse error and pattern. Right? That explains the error message you're getting, which is otherwise perhaps not so obvious, but here you really have to put the parentheses. Okay. Now the next is structure. So this function looks complicated for a function over lists, right? So it has 4 cases, and we have seen that typically functions over lists have 2 cases only. So that in itself should make us suspicious, right? And of course, there are functions over lists that need more than 2 cases if there is actually special behavior. But we should always question whether these 4 cases are actually necessary. Every extra case increases the cognitive burden of understanding the function. It increases the possibility to make mistakes. And if cases are just redundant, for example, if they're subsumed by other cases, then it is much better to omit them, right? Let's look at the cases. And so I want to start with line 8 here, with this one, with the 2-element list case. That's perhaps the least usual one, right? I mean, the typical cases, if you remember, for a function over lists are to match on the constructors of the list type. And the constructors of the list type are the empty list and cons. So it is rather plausible that we need a case for the empty list, and it is rather plausible that we need a case for cons. But these cases in the middle, they are somewhat suspicious. And sometimes cases for 1-element list are required, but cases for 2-element lists are really rare. So let's have a look at this one, right? So we say the product of a 2-element list is the product of the 2 elements. So that is definitely correct, but is it needed? Is it needed here? So one thing you can do is you can comment out the case, and you can observe that the function still type checks. We don't get any complaints. And then, of course, you can try out whether the function still behaves correctly. And we can see that it still gives the same results as before. So that all looks plausible. But we can also apply equational reasoning if we really want to be sure, right? We can look what happens with a call product EL1, EL2, according to our function definition. And that works according to the principles already discussed. So we first observe that the list is just syntactic sugar, right? So really what we have here is a sequence of conses and nils, right? And then we look, how does it match the cases that we have? So this matches the final case at the moment, right? And so then we get EL1 times product of EL2 cons nil, okay? And now we cannot really reduce the product because we have kept this symbolic, but we can unroll the product and the recursive product application. Sorry, we cannot compute the multiplication, but we can unroll the recursive product application further, because this again matches, but now we have to be a little bit careful because this is a 1-element list, and even though we have now desugared this matches the case in line 7, the case for the 1-element list. So this actually gives us EL1 times EL2, okay? And that's it. And now we see that by applying equational reasoning to this expression on the left-hand side, we got the right-hand side using the other cases. And that really is a proof, essentially, that the case that we had here is subsumed by the other cases, and we don't really need it, okay? Now this still leaves the case for the 1-element list, which is suspicious. Now clearly that is also correct. If you have a single number and you want to compute the product of that single number, then it is just the number itself. That makes sense. But here the question is, like, do we need it? Because typically we can reduce something to the base case. So what happens here if we remove this? If we just reduce something to the base case, and we have a product here, and we hit the base case in the end. And let me reload and look at this. Oops! Now we see that suddenly things are different. Okay, so we get 0 for this product, and we get 0 for this product, and in fact we get 0 for any product. And why is this? Because if we recurse over a list, then ultimately we hit the empty list, and then for the empty list we give 0. So we always have 0 occurring as a factor in our product. And that means that the whole product ends up being 0. Okay, so this does not work. The one element list case is not subsumed by the others, but it does make a little bit suspicious. Why do we use 0 for the product of the empty list here in the first place? And that is a good question, right? So what should we choose as the product of the empty list? Why should it be 0? Right? Why should it not be 1, for example? If we said that the product of the empty list is 1, right, then all of a sudden we have the right results, right? And all the right results are back. And then we could omit the case for the empty list, for the one element list, because now, again, if we apply equational reasoning and we compute the product for this one element list, then the second case applies and we get EL1 times the product of the empty list. And now the product of the empty list is 1, right? And we know that multiplication with 1, we know the computer will still perform this step, but it's a cheap step. We know that multiplication with 1 is just the number itself. And in fact, I mean, even GHC may apply this kind of optimization. So what is the right choice for the product of the empty list? And this is a good question to look at slightly more generally, and perhaps deserves a separate video. But I would argue very strongly that 1 is the right choice and 0 is a wrong choice for the product of the empty list. And you'll find that the library in Haskell, the library version of product, of course, also returns 1 for the product of the empty list. And the reason is that 1 is the neutral element of multiplication. Exactly has this property that multiplying something with 1 does not change it. And we are essentially mapping a list structure here to a multiplicative structure. And for the function to be non-surprising in its behavior, and simple and uniform in its behavior, that is just the right choice. So for example, we would like to have the following property. If we have two lists, xs and ys, and we append them using ++, right? ++ was the list append operator. That just puts two lists together. Then it would be a reasonable expectation to say that this should be the same as product xs times product ys. Now this is not a definition, this is sort of a property that we would like to hold for arbitrary choices of lists xs and ys, right? If we have two lists of numbers, we want to compute the product of all of them, it should be intuitively the same whether we take both lists together and then compute their product, or whether we keep both lists apart and compute the products individually and then multiply the results. It should not change the result, right? Now, xs and ys could both be empty, right? And if xs or ys are empty, then for this property to hold, we need the product of the empty list to be 1. Otherwise, we would have to exclude the empty lists from this property, from this desirable property. And just as we had a special case for the empty list in our original version of product, we now would have to start treating the empty list special in lots of different cases. If we have to make exceptions for something for no good reason, then it should always make us suspicious, right? So here, there is no need for all this if we just agree to map the empty list to the neutral element of multiplication, right? So the empty list is the neutral element of list append, right? If we append something with the empty list, then we get the original list out. And we map it in such a way that the neutral element for one operation, for list append, becomes the neutral element for another operation. And this is a general thing that you'll see very often, right? So that is also the reason why the sum of an empty list should be 0, not because 0 is somehow special, but because 0 is the neutral element of addition, right? Because adding something to 0 does not change the number. Okay, so if we make this change, and that arguably makes the original function even semantically incorrect, then we can simplify further, and then we get this. And then we are much better off than in the beginning already. So is there anything left? Well, yes, I would say there are some things left. So one thing that I would definitely still address is the names of the arguments here, fun and array. Fun suggests function, array suggests array. Both of these are misleading, right? Fun is not a function. It is a number here, an integer here. So we could either choose something very generic, something like x, or perhaps something that suggests number, right? Num, I don't know, but I mean, I would probably go for x or I. Okay, I think that is a better option. And array, there are many languages where this square bracket notation is being used for arrays. And arrays are data structures which are typically stored in blocks of memories and allow efficient access to every element of the array, constant time access to every element in the array. That is the connotation you have with arrays. Haskell lists do not have this property. Haskell lists are linked lists in memory. They are pointer structures. In order to access an element that is further down the list, you have to traverse that pointer structure. So please call them lists, don't call them arrays. Right? So you could use list rather than array here, but very common in Haskell is to use this xcons access pattern, where you say if you split a list into two things and the contents of the list are very generic, then you have a single item x as the first argument of the cons, and you have another list with multiple items at the tail of the list, so the second argument of the cons, and access suggests that there are multiple items, right? So that is a good choice. Okay, so now there is still, I would say, a few things left that are worth discussing. So one aspect is that the type signature we have here for the product function is not the most general one, and that is at least worth mentioning, right? So if we comment out the type signature, we see that the inferred type signature here says that this is actually something that could be overloaded over anything in the num class, because both the number 1 that we're using here on the right-hand side is overloaded, and the product operator is overloaded over the num class as well. So we are not using anything on the right-hand side that says that we actually have to deal with integers. And it would be, if we write this kind of function from scratch, it would be a reasonable choice to give it the most general type, to give it this num overloaded type. On the other hand, if you're asked to implement a particular interface, and often in an industry situation where you are arranging with other teams, you're supposed to implement a particular interface, it's typically a good idea not to change that interface, even if you're making it more general here, right? So this is a little bit of a trade-off. And also in the exercises, typically if I give you a type signature, then I expect you to leave that alone. Again, if you make it more general, that is fine, but certainly you should never make it more specific. That should always be a strong warning sign, right? Another point is that this definition of product is actually not ideal in the algorithmic sense. It has a so-called space leak. If you if you compute the product of a large list, this will take a lot of memory, where computing the product of a large list should in principle not take a lot of memory. But this is an algorithmic aspect, and we'll talk about it separately at a different time. So I'll leave it out of this particular video, where I wanted to focus on stylistic issues mostly.